was gaining prominence, and this was before it was even relevant at the time. In 1958, he became the first person to define the programs on which electric calculators ran. In the 70s, he was chairman of a research committee that warned that aerosol spray cans would damage the ozone layer. He also developed the fast Fourier transform, an algorithm with wide application to the physical sciences. It helps astronomers determine the spectrum of light coming from a star much faster than previously possible. He was also part of a group of Princeton professors that inspired the Hubble Space Telescope. President Nixon awarded him with the National Medal of Science in 1973. From 1960 to 1980, he helped design the polls that NBC television network used to predict and analyze elections today. It wasn't until his later years much of his important work came in a field that statisticians called robust analysis, which allowed researchers to devise credible conclusions even though the data they were working with was flawed. Many of his peers saw him as an outsider, and he loved to argue. He's best known for developing the box plot in 1970 in his book Exploratory Data Analysis, which also included the stem and leaf display. This wasn't uncommon for John Tukey because he was a very visual person and believed that a mathematician, whether you were a professional or an amateur, should look at the data and kind of draw assumptions from it, and then look for a theorem rather than the other way around. His statistical interests were many and varied, but I'm going to first talk about Tukey's quick test. You'd use the Tukey quick test when comparing data from two different samples and testing the hypothesis. The null hypothesis in this situation would be that the medians are similar, and the alternative hypothesis would be the population medians differ. When talking about averages, we often discuss the mean rather than the median, but with the Tukey quick test, it is most common to use to compare the medians. Say we have data from two samples and want to compare their averages. You start off by creating a back-to-back stem and leaf diagram to visualize the data from both samples and take note of the shapes that the data creates. Arrange the observation in each sample from smallest to largest. Determine the smallest and largest observations of the combined samples. If both observations come from the same sample, or if either the smallest or largest number occur in both samples, this test is not appropriate. If the smallest and largest samples occur in separate samples, then designate the sample with the smallest observation as S and the sample with the largest observation as L. Now you're going to look for the TS and TL values. Look at the observations in sample S and determine how many values are smaller than the smallest value in sample L and let that represent TS. Then look at the observations in sample L that are larger than the largest values in sample S and let that represent your TL. Now you calculate the T, which is just the sum of TS and TL. Going back to the hypothesis, your null hypothesis is that the population medians are similar, and your alternative hypothesis is that the medians are different.
So,
if your T is larger than 6 for a 0.05 level of significance, then you would reject the null hypothesis and conclude that the population medians differ. If your alpha, or level of significance, is 0.01, then your T would have to be larger than 9 to reject the null hypothesis. The second statistical contribution he made I'm going to discuss is known as Tukey's range test, or Tukey's honest significant difference test. This is a single-step, multiple comparison procedure and statistical test. This is used when analyzing multiple means from different groups in the sample. Experiment designs include many types of tests. Before running an experiment, a researcher must design the experiment, including the tests he wished to use in the data analysis procedure after the test. In some circumstances, the data analysis indicates that there may be some interesting information that cannot be analyzed through the pre-planned test. This is when the Tukey HSD test comes in handy because it allows you to further research the matter even after the data has been connected and analyzed initially. This makes it a post hoc analysis, which means looking at the data after the experiment has concluded for patterns that were not specified previously. It is performed after an analysis of variance test. The purpose of the Tukey HSD test is to determine which group averages in the sample differ. While an analysis of variance test can tell you whether the groups in the sample differ, it cannot tell you which groups are different. This test can clarify to the researcher which groups among the sample have significant differences. This test works through defining a value known as the honest significant difference. This value is a number that acts as a distance between the groups. It is calculated by first dividing the mean squared error within the analysis of variance by the total number of data points for a given group. Take the square root of the resulting value and multiply it by the student range distribution. The more means that are compared, the more likely a type 1 error will be made. The Tukey HSD test is based on a variation of the t-distribution that takes into account the number of means being compared. This is called the student range distribution.
Mm-hmm.
The end result is the honest significant difference, and it represents the minimum distance between two group means that must exist before the difference between the two groups is to be considered significantly different. A case study was done on smiling and leniency using the Tukey HSD test. In this study, the effect of different types of smiles on the leniency showed to a person was investigated. They used the same person and took pictures of him making different facial expressions, then used side-by-side comparison to note the difference between the expressions. An obvious way to proceed would be to do a t-test of the difference between each group mean and each of the other group means. This would lead to multiple comparisons, and for this example, let's just say there's 6 comparisons total. The issue with this approach is that if you did the analysis, you would have 6 chances to make a type 1 error. Therefore, if you were using the 0.05 significance level, or alpha, the probability of making a type 1 error on at least one of these comparisons is greater than 0.05. This goes back to the idea that the more means being compared, the more likely it is that you'll make a type 1 error.
Mm-hmm.
That is why using the Tukey HSD test is important, because it takes into the account the number of means being compared. It is not unusual to obtain results that on the surface appear paradoxical. For example, the results of this case study may appear to indicate the false smile is the same as the miserable smile, while the miserable smile is the same as the neutral control, and the false smile is different from the neutral control. This apparent contradiction is avoided if you are careful not to accept the null hypothesis when you fail to reject it. The finding that the false smile is not significantly different from the miserable smile does not mean they are really the same.
Yes.
All it really means is that there is not convincing evidence to say that they are different. And that is all.
Right.
So a lot of more new information, and this talk, as the previous talks, did the main thing that I want these talks to do is serve to educate the classmates about some new statistical information. And it certainly did that for me, and that amount of statistics that you've shown was very educational in that respect. I felt that there was a bit too much detail on the statistical content to be able to perhaps follow verbally. You might actually need a smartboard to bring some of that across, but still your thinking was so logical and clear that for myself I was able to follow you. So that part did work out well. I think that we could have used more of a conclusion. I think the stop was a little bit abrupt, but that's okay. Your content was very good. We didn't find much about the humanity of this man. I mean, how many beers he liked to drink or stuff like that. We could have embellished it with a little personal stuff. Your statistics was fantastic. And the thing that I'm most pleased about as I listen to all of these talks for myself is that we can understand them. When we're talking in here about type 1 errors and we're talking about statistical significance, everybody in the class knows what we're talking about, whereas 7 weeks ago, nobody would have. So this class has brought everybody from here to there, and now you're comfortable with this type of terminology and these type of topics at a very professional level. So everybody give yourself a little pat on the back for that aspect. Okay, moving forward, we've got 2 talks left, one here and one there. So Jeff, would you like to wait or would you like to talk? Okay, Jeff's on, Lori's last.
All right, everyone hear me all right?
Yes, audio is very good. It's perfect. Thanks, Jeff.
Wonderful. All right, my presentation is actually about statistics involving social media and the influences of it, as well as how accurate it is. So I want to start off with some more, just kind of some fun statistics here, but I want some information from the class. So out of both classes, how many people here have a social media network? I mean, we're talking Facebook, LinkedIn, Twitter, any one of them. Okay, pretty much everyone's raising your hands. Okay, so that's 100% just for us. Okay, so the interesting part of it, so let me go back. With the amount of people that we have on social networks, how many, with another show of hands, believe everything you see on those social networks? Okay, so that's even better. 100% say no, that's actually a good thing. One of the first things we are taught in this class is to stay objective as regards to statistics, especially when they're provided by all kinds of different places and information sites. Some fun facts, or actually terrifying if you really think about it, are how many people are actually on social networks. Now, the facts I've got here are just from Facebook. This is just Facebook. This is not any other social networks. Worldwide, there are over 1.39 billion, with a B, monthly active Facebook users. Now, that's an impressive number by itself, but knowing that there are an estimated 4.4 billion, with a B, without internet in the world. Now you're looking at literally half of the people on the planet with internet are on Facebook. Every day, of those people, 4.5 billion likes are generated every day. This is actually a 67% increase from 2012 to 2013. So in 1 year, there was a 67% increase in how many likes are generated daily on just Facebook alone. Something else that is interesting about this is that every second of every day, 5 new profiles are created just on Facebook. This is since 2012. So I mean, in the few minutes that I've even started this presentation, you're looking at over 100 to 150 new profiles that have been started on Facebook alone. Now, the reason stats like this are important, especially regarding statistics by themselves, is that if in business, these kind of numbers are important to utilize for how you market. Per Facebook's information that they provide on their sites, 42% of marketers report that Facebook is critical or important to their business. That means that there are entire businesses out there that depend on the advertisement that Facebook provides for their companies. So after those fun little facts, the point of being able to stay objective in regards to statistics, especially in regards to social networking, is because there is a lot of information that is put out there that provides a lot of definite numbers. So, but how true are they is always the question that you have to ask when you read this. The example I picked was, and actually still is, one of the most controversial things that have actually ever came up on a social network. In this case, it started on Twitter and grew into Facebook and LinkedIn and things, and still to this day, 3+ years later, still pops up on these same feeds. The actual post was about rape statistics. Kind of a morbid topic, but still something that you see utilized all the time in social media networks. So the original Twitter post was a hashtag I stand with Jackie, because 90% of rapes go unreported. Just 2% reports are false. Power is still with the perpetrators. This website, and actually a website that is on social media as well, decided to fact check this information. Where this graphic broke down was, is out of 1,000 rapists, 100 are reported, 30 face trial, and 10 were jailed. Now, this particular fact checker actually broke this down into 5 separate sections, pretty much going over each of the information that it was provided. So, one first incorrect assumption to start with was that this statement made it seem like there was 1 rape per perpetrator. Now, granted, outside studies show that the frequency of rapes being perpetrated multiple times by the same person are actually much higher than the one-on-one that we are used to seeing. So we go on to the how many are reported. This said that out of 1,000 rapists, 100 are reported, so around 10% per what is brought in there with the plus or minus. According to the Abuse and Incest National Network, there is an estimated 40% of rapes get reported to the police. This is actually very similar to criminal victimization rates taken by police forces that say 35% of rapes are reported. So already in just one piece of information, they have debunked something that created a lot of controversy on social media networks. Another portion of this, which was saying how many people were jailed, it also says that 19.5% to even 40% from information that came out of police forces saying that people were arrested. Now, this does not necessarily mean jailed or not, but again, it's the terminology that is utilized in this particular statistic that can skew information to show bias towards their particular viewpoint on this subject. So the final thing that I wanted to point out on this fact checker site is the fact that the page that actually originally posted this admitted in an interview that there were errors in their statistics, but that they also refused to change them. Let's see. The only thing that was stated on this interview was that they posted a hyperlink to go back to the original site where they got their information. Too bad when you go to this hyperlink, it actually isn't a hyperlink, it's not even a real page. So again, we're looking at a social media site which created such a massive level of controversy through social media networks on Twitter, Facebook, and 24-hour news networks. I mean, when this came up 2-3 years ago, this was the news for about a week. And yet, the person who originally posted it can't even back up their information. So this is the power of social media networks to be able to disseminate information as well as false information. Now, the other side of this, which is even scarier, is the power of being able to influence people's ideas, influence people's thought processes through these websites, through these media networks. Facebook actually got into a lot of trouble this past year. If people actually remember hearing on the news, they were doing a mood study on Facebook. They utilized over 689,000 users' profiles to see if they could, through adding more negative or more positive posts and controlling their news feeds, they wanted to see if they could influence a person's emotions. They tracked this by watching how positive or negative their posts were after the influence. So, let's see. 689,000 users' homepages, and found it could make people feel more positive or negative through a process of emotional contagion. So quite literally implanting what Facebook wanted or did not want them to see if they could influence their very mood. Facebook filtered users' news feeds, the flow of comments, videos, pictures, and web links posted by other people in their own social network to see if they can influence this. One test reduced users' exposures to their friends' positive emotional content, so good news, happy thoughts, and resulted in fewer positive posts from that user. When the other test reduced exposure to negative emotional content, the opposite effect happened. So quite literally, with this emotional contagion that they were implanting, Facebook found out that they could influence the very mood and emotions of a very, very large population of people. Kind of scary when you think about how much you look at Facebook. Now, where the final scary part of this comes up is that this study was found to be so successful, even though it was that controversial, is that the U.S. military has now studied how to influence Twitter users in a DARPA-funded research. So now the United States military, United States government has decided to get involved in this thought process in the idea of national security and defense. They bring up the point in here of if they would be able to influence an enemy's country, such as, I mean, you have countries like Iran who do have internet, have Twitter pages. Would you be able to influence the enemy into having a riot? So they've actually discovered in this research that by engaging 3,761 people on Twitter around the topics of public safety and bird flu, the researchers added that unlike existing work, which often uses social network properties, our feature set includes personality traits that may influence one's retweeting behaviors and may influence their ideologies as a result. So social media is changing the way people inform themselves, share ideas, and organize themselves into interest groups. So by utilizing that information and by people not being informed about what they're reading, understanding the statistics about it, understanding the numbers in regards to it, you are actually opening yourself up to influence by a force that you thought was just supposed to be for fun. So I guess the final portion of this presentation would be watch what you read on Facebook, trust no one, and make sure you know how to fact check yourself. As the class stated at the very beginning, always be objective with any statistics you receive. Thank you.
Jeff, I think you shocked everybody. You certainly shocked me.
That was kind of the intent.
And it worked. For the first 5 minutes of your talk, I wasn't sure where you were going. I actually wasn't really sure what your topic was. You didn't really state it clearly or at a sufficient length in the beginning. But after you got into it, then I picked up on what you were doing, and you finished very, very strong, and you really raised a new spectra about us being manipulated by Facebook and manipulated by social media. And of course, as a statistics instructor, the first thing that comes to my mind is how could they possibly control all of the variables as to whether their positive posts are actually causing an emotion or whether it's just coincidental with other things going on in the person's life. You want to speak to that?
One of the scarier things I found about that was that I couldn't find information.
Jeff, just a moment. We got an F-16. Oh, no, we got a P-2. Okay, continue. Yeah. Repeat, please.
That was one of the scarier things about that, is that no matter how much I tried to research about that,
Yes.
I could not find reliable information in regards to that.
No,
like it
you
was
see-
wiped from the internet,
Right.
how they were able to
I would
control
like
the
to
area.
point out that of our 4 talks, this is the first one that has set me off and has started interaction. So again, we've had 4 different kinds of talks, all of which were excellent in their own way. And this is the first talk that is audience focused. And the audience feels involved in it. You definitely attacked us. You started out involving us right away with a show of hands, which is a very good tactic to involve your audience. So you, more than the other speakers, have involved us. And you didn't show us a statistician and you didn't show us statistics, but you did unveil a current real-life situation that's going on around us. So let me continue that vein. Does anyone here want to pose a comment or a question about this? Okay, I'll continue with some of my own. Can anyone tell me how it would be possible for Facebook to decide that they were the cause of the effect that they were measuring, and not that it was something else in the person's life that was causing the effect? In other words, do we have correlation or causality? Oh, by the way, Minnie, I see we have a new member of the class. Well, welcome aboard. So this seems to need a lot of explanation, but Jeff, you said the results were very conclusive and they were backed up and that nobody's really challenging them. True?
The challenge that's coming from it isn't so much the information that they've come, is more that the controversy of them going into people's, what they would assume to be private lives.
Well, yeah, that's a question of ethics. I was going to come to that in a moment. But first, do you challenge the statistical study as that they did as accurate or inaccurate? Just the statistical study itself?
For each individual study, I couldn't find definitive information, but with the military being involved in it, apparently someone thought it was.
Someone believed it. I go along with that. But even though it's been raised the first time, it takes some amount of time before it's believed or disbelieved. And the invasion of ethics as to they're actually manipulating people that don't expect them to be manipulating them is a question for the ethics course. We do have a course in information ethics, IT ethics here, and that certainly would be a hot topic there if you do take that course. So you have introduced us to a new dimension about statistics, and so that was a very good thing to have done. So, yeah. Okay, we have one talk to go. So Laura, would you like to come up and do that? First a second, let me give you the big stage. So Iwakuni can do that for you. Okay, please. So we have Laura speaking. Hi.
Okay. So I did my presentation on George Bernard Danzig. He was an American mathematical scientist that made some very important contributions to operations, research, computer science, economics, and statistics. He was the son of immigrant parents. Mother was a French linguist and father was a Baltic German mathematician. His father had a lot to do with his influence in his interest later on in life in math and statistics and everything. He received his bachelor's degree from the University of Maryland in 1936. Found it pretty interesting since we are a branch of the University of Maryland. He received his master's degree from the University of Michigan the following year. While he was there, he decided that he didn't really like abstract math anymore, that he preferred statistics and enjoyed his statistics class a lot more. So what he did was he left the graduate program at Michigan and he moved to Washington to work as a junior statistician on a project which was named the Urban Study of Consumer Purchase. The project he worked on was in the U.S. Bureau of Labor Statistics. He worked on that from 1937 to 1939. During that time, he did a lot of research and reading done by various statisticians, mathematicians, professors, and whatnot. The one, I guess, that stood out to him the most and he was most interested in was Professor Jerzy Neiman. He was a professor at Berkeley, and George wrote him a letter asking him if he could get him a teaching assistant position at the university, at Berkeley, so that he could study under him and finish his doctoral studies. While he was at Berkeley is when he was first recognized for his ability or contributions into statistics. In 1986, he did an interview for the College Mathematics Journal where he talks about the events that led him to this first recognition. He tells a story about how one day he was running late to class and he was going to a graduate level statistics class taught by Professor Neiman, and when he got there were already 2 problems written up on the board. Because he was late, he assumed that they were homework assignments, so he just copied them down in his notebook. But what he didn't know is that they were examples of 2 famous statistics problems that were thought at the time to be unsolvable. A few days later, he went to his professor's office to turn in his homework, and he was apologizing because it had taken him a couple of days to finish the assignment, because he thought that it was just a little harder than what they usually get assigned for homework. Professor Neiman, knowing that the problems were unsolvable, or so he thought, didn't really think much of it and just told him, okay, put them on my desk and I'll grade them later. About 6 weeks later, on a Sunday morning, Danzig and his wife were woken up by Professor Neiman banging on his door. He came in and told him that he had written an introduction to one of his papers, one of the 2 problems that he had turned in, and asked him to read it so that he could submit it for publication. The very next year, when Danzig was trying to find a topic for his thesis, I can't remember if it was a professor or a counselor, kind of suggested to him to use his problems as his thesis statement. So he just pretty much put him in a binder and turned it in, and that was his thesis for grad school. Eventually, his second problem was published, but it didn't happen until after World War II. He ended up getting his doctorate from Berkeley in 1946 after he put his studies on hold again for World War II, where he served in the Air Force in the Office of Statistical Control. He later rejoined the Air Force after he received his doctorate. In 1947, he made the mathematical contribution that he's most famous for, and that was the simplex method of optimization. He developed this method from his work in the United States Air Force, where he served as a mathematical advisor to the comptroller and became an expert on planning methods that were solved with just regular desk calculators. The term in the military that they used was programming for this method, which at the time referred to plans or schedules for training, logistical supply, or the deployment of troops. He mechanized the process by introducing programming in a linear structure. After he discovered the algorithm, he did a test application of the problem on the eating well at a minimum cost. So that's how he initially tested everything out with that situation. Talking about linear programming in 1947, an article later, he said that linear programming, this is a quote, is viewed as a revolutionary development giving man the ability to state general objectives and find, by means of the simplex method, optimal decisions for a broad class of practical decision problems of great complexity. So linear program was used to allocate resources, plan production, schedule workers, plan investment portfolios, and formulate marketing strategies. So basically, what it was is by using the linear programming, you're able to find the best and simplest process decision for a problem. It's made a very big economic impact on today's industrial world. While he was in the Air Force, after a while, he kind of grew out of his work and decided to leave the Air Force and started working with the RAND Corporation as a mathematician in 1952. There, he led the work for implementing linear programming onto computers. However, again, after a while, he felt that his work at the RAND Corporation was not providing him with enough fresh ideas. So he left and became a professor of operations at Berkeley in 1960, which is where he got his graduate degree from. After a few years there, he was offered another position at Stanford University, a teaching position, where he started in 1966. He liked it there, and he stayed at Stanford, where he taught and published as a professor of operations research and computer science until about the mid-90s or so. He has said that he continues to find it interesting that the original problem that started his research is still relevant today, especially dealing with the problem of planning or scheduling dynamically over time. He thought that if a problem like that could be solved, it could eventually contribute to the well-being and the stability of the world. He was a member of several academies. He was a member of the National Academy of Sciences, the National Academy of Engineering, and the American Academy of Arts and Sciences. Throughout his life, he was awarded many things and given many honors. In 1976, he was awarded the National Medal of Science, and it was actually presented to him by President Gerald Ford, which was pretty cool. And then later, in 1977, he was awarded the National Academy of Sciences Award in Applied Mathematics and Numerical Analysis. After he retired from teaching from Stanford, he and his wife stayed in Stanford until he died at the age of 90 on May 13th, 2005.
Wow.
And that's about it.
Okay. So. A very nice talk, a good speaking voice, good facts, well researched, and good talking as opposed to reading. And we understood very well what you're saying. Communication was very, very strong. Did a very, very good step-by-step development of the simplex method. And not too much can be said about this, or you can't say too much about this. This introduction of linear programming in the 1940s was absolutely revolutionary. And one of the things that it was first applied to was that America at that time was trying to send ships and supplies across the Atlantic Ocean to support the World War that was taking place in Europe, and the German submarines were decimating them. So linear programming was used to how to optimize the division of supplies among the ships and the routes that the ships takes and the other tactics that they would use so as to minimize the amount of destruction that would be taking place by the submarines. So this is one of the first applications of linear programming. Linear programming is also noteworthy because when we teach the intermediate algebra here, we stopped just before that topic. So it's the first topic that we skip in that course. Maybe now we should revisit that and see if we want to add it. Another noteworthy fact was that around the years 1960, the preeminent university on the West Coast was the University of California at Berkeley. And Stanford was a young child that aspired to be as prosperous in academic, so they were stealing professors from Berkeley at first opportunity, and apparently they stole Danzig, and he liked the switch very much. And now, if anything, people would say that Stanford is at least the equivalent of Berkeley. So they did the things that they needed to do and got to the place that they wanted to got to. In this talk, we could have used a little bit more statistics about the innards of the simplex method or something of that sort, but still a very good talk. So there we go on that. Now, with that, we bring to a conclusion tonight's performers, and the spotlight starts to be turned off. There's still 2 or 3 talks to be presented, but those students are going to present them to me one-on-one, and that'll be done later in the week. So don't cry, anybody, but we're going to bring this course to a close right now. So Iwakuni, any closing remarks?
Yes, sir. Sir, just want to say thanks for your patience. I know you were extremely patient with the majority of us. I think I speak for my colleagues. I'd also like to thank all the students up at your location that put a lot of this work on the whiteboards, on the extra class on Tuesdays. It was extremely helpful. So thanks to you guys. I just want to wish everybody the best in your educational endeavors.
You're a very gracious person, Jamie, and I do try to control my irritation. And I don't think much of it showed. But no, it was very easy to be patient with all of you because you're also serious, hardworking, and enthusiastic students. So it was not hard for that to take place. And once again, yes, the Misawa people should be thanked for the work that they put on the whiteboards and sent out of there. So it's nice of you to speak to them about that. So with this, we'll bring the course to a close. So here it is, we're done. Woo! Okay, done.